What if I told you there is something in the universe so enormous, so overwhelmingly powerful, that if it suddenly appeared at the center of our galaxy, every single star in our night sky would vanish behind its brilliance forever? It sounds like science fiction, but it is real, and the story behind it is one of the most astonishing discoveries humanity has ever made. Stay with me, because what you are about to learn will completely change the way you look at the universe. Before we go any further, pause for a moment. Take a breath and clear your mind. What we are about to explore is not just another story about space. It is a journey to the limits of what human understanding can describe. By the time we reach the end of this story, the night sky above you will no longer feel quiet or distant. It will feel immense, ancient, and far more mysterious than it ever did before. There are regions of the universe where the familiar rules of reality begin to break down. In these places, gravity bends space and time into strange shapes that seem almost impossible. Time slows dramatically, light struggles to escape, and the very fabric of the cosmos stretches toward extremes that challenge our understanding of physics itself. At the center of these environments lie black holes. But today we are not talking about an ordinary one. Today, we are traveling to one of the most extreme objects ever discovered by astronomers. It is a darkness surrounded by unimaginable energy, a cosmic engine powerful enough to influence entire galaxies, and the light we see from it today began its journey toward Earth when the universe was still young, long before our solar system even existed. Its name is TON 618. By the end of this journey, you will understand why this single object, located billions of light years away, represents one of the most fascinating frontiers in modern astronomy. It sits at the edge of what physics can comfortably explain. It forces scientists to question how such enormous structures could form so early in the universe. And perhaps most importantly, it reminds us just how small our place in the cosmos truly is. But to understand TON 618, we need to go back to the moment it was first noticed by human eyes. The year was 1957. At the Tonantzintla Observatory in Mexico, astronomers were doing the patient and methodical work that has defined astronomy for centuries. Night after night they photographed the sky, cataloging stars, galaxies, and faint objects scattered across the universe. Their goal was simple: record what was there so future scientists could study it in more detail. In one of those photographic plates, buried among thousands of tiny points of light, they noticed a faint blue object. It did not appear remarkable. It looked like just another distant star. The astronomers simply labeled it with a catalog number TON 618 and moved on. For years, no one paid much attention to it. It was just another entry in a long list of celestial objects, but science has a way of turning ordinary observations into extraordinary discoveries. Sometimes the most unremarkable dots of light hide the biggest secrets in the universe. Eventually, researchers pointed a spectrograph toward this faint blue point. A spectrograph analyzes the light from an object and reveals the hidden information inside it. It can tell scientists what elements are present, how fast something is moving, and even how far away it might be. When astronomers analyzed the light from TON 618, they realized something astonishing. This was not a star. It was something far more powerful. The light carried signatures of extremely energetic processes, the kind normally associated with the violent centers of distant galaxies. What appeared to be a tiny star was actually the blazing core of a galaxy billions of light years away, powered by something extraordinary at its center. But before we reveal exactly what is hiding there, we need to understand just how far away TON 618 really is. Because distance in space does more than separate objects. It acts like a time machine. TON 618 lies more than 18 billion light years away from Earth. When astronomers observe it, the light entering our telescopes today actually began its journey more than 10 billion years ago. At that time, the universe itself was still young. Galaxies were just beginning to grow and evolve. The first generations of massive stars were lighting up the darkness that followed the birth of the cosmos. So when you observe TON 618, you are not looking at something happening now. You are seeing a preserved image of the distant past. A snapshot from a time long before our solar system existed, before Earth formed, before the atoms in your body were created inside ancient stars. That light has been traveling across the universe for longer than our sun has even been shining. And here is the haunting part. What we see today is only the ancient version of Ton 618. Whatever it looks like right now, in the present moment, we cannot know. That information is still on its way toward us and will not arrive for billions of years. In astronomy, we are always looking into history. Now let us talk about what Ton 618 actually is. It belongs to a rare class of objects called quasars. The word comes from quasi-stellar object, a name scientists gave them when they first discovered these strange sources of light during the 20th century. At first, quasars confused astronomers because they appeared small, almost like stars, yet they produced unbelievable amounts of energy. If the distance measurements were correct, these objects had to be brighter than entire galaxies. For years, scientists debated the explanation. Some believed the distance estimates were wrong. Others thought the energy calculations must contain errors. But as telescopes improved and observations accumulated, the truth slowly became clear. Quasars are the incredibly luminous centers of young galaxies, and the source of their power is one of the most extreme processes in the universe. Supermassive black holes consuming enormous amounts of matter. Imagine a massive black hole sitting at the heart of a galaxy, rich with gas and dust. Gravity pulls surrounding material inward, forming a spinning structure called an accretion disk. This disk is made of superheated gas swirling around the black hole, like water circling a drain, but on a scale that stretches across billions of kilometers. As the material spirals inward, friction and collisions heat it to extreme temperatures. The disk begins to glow intensely, emitting energy across the entire electromagnetic spectrum. Radio waves, visible light, ultraviolet radiation, X-rays, and even gamma rays blast outward into space. The result is a cosmic lighthouse so bright it can outshine an entire galaxy. This is what makes quasars visible from billions of light years away. Ton 618 is one of the most powerful examples ever discovered. Its total energy output equals the combined light of 100 trillion suns. That number is almost impossible to visualize, but imagine replacing the center of our Milky Way galaxy with Ton 618. Its light would overpower every single one of the galaxy's roughly 400 billion stars. From Earth, the sky would look completely different. Ton 618 would shine about 23 times brighter than a full moon, flooding the night with constant brilliance and erasing the darkness humans have known for all of history. But as incredible as that brightness sounds, it is only a side effect of something even more astonishing hidden at the center. Because inside this blazing quasar lies the true giant driving everything, a black hole so enormous that its scale pushes the limits of what the human mind can grasp. At the center of the blazing quasar, Ton 618 lies the true engine behind all that unimaginable light. Hidden beneath the swirling storm of radiation and plasma is a black hole so massive that it stretches the limits of what modern physics can easily explain. Its mass is estimated at 66 billion times the mass of our Sun. Pause for a moment and try to grasp what that means. The black hole at the center of our own galaxy, known as Sagittarius A*, already seems enormous with a mass of around 4 million suns. For most people, that number alone feels impossible to comprehend. Yet Ton 618 is more than 16,000 times heavier than the gravitational giant at the center of the Milky Way. Numbers like these quickly move beyond ordinary intuition. The difference between 4 million and 66 billion is so large that the human mind struggles to feel it in any meaningful way. Both numbers exist far outside everyday experience. But scientifically, that enormous gap represents a cosmic scale that few objects in the universe can match. To better understand it, imagine the boundary that defines a black hole's edge, the point where gravity becomes so strong that nothing can escape. This boundary is called the event horizon. For Ton 618, that invisible sphere stretches roughly 400 billion kilometers across. That distance is difficult to visualize, so let's bring it closer to home. If Ton 618 were placed where our Sun sits today, the event horizon would swallow the entire solar system. Mercury, Venus, Earth, Mars, the asteroid belt, Jupiter, Saturn, Uranus, Neptune, and even the distant orbit of Pluto would all lie safely inside the darkness of this single object, with room still left over. Everything we know as our planetary neighborhood would disappear beyond the point of no return. And yet, the event horizon is only the beginning of the story. To truly understand how extreme Ton 618 is, imagine traveling toward it from deep space. At first you would not see the black hole itself. Black holes do not emit light. Instead, the first thing you would notice would be the incredible glow surrounding it. The accretion disk would dominate your view long before the black hole's shadow became visible. This enormous disk of gas and dust would shine across every wavelength of energy at once. Visible light would blend with ultraviolet radiation, X-rays, and other forms of energy that the human eye cannot normally see. It would look like a cosmic storm of light stretching across space. But as your spacecraft moved closer, the universe around you would begin to behave in ways that feel deeply unfamiliar. A glowing ring would start to appear around the dark center of the black hole. At first it might seem like an illusion, but it would be completely real. This ring exists because gravity near a black hole is so powerful that it bends the path of light itself. Light coming from stars behind the black hole would curve around it, wrapping into a circle that becomes visible from your point of view. Scientists call this region the photon sphere. In this zone, gravity is strong enough that photons, the tiny particles that make up light, can actually orbit the black hole. They circle again and again, trapped on unstable paths before eventually falling inward forever. The closer you travel toward Ton 618, the stranger everything becomes. Light from the inner regions of the accretion disk would begin to shift in color. Waves of energy trying to escape the intense gravity would lose energy along the way. Blue light would gradually stretch toward yellow, then orange, and finally deep red before fading beyond the range of human vision. This phenomenon is known as gravitational redshift. It is as if the black hole slowly drains the color from the universe itself. And then, there is time. According to Einstein's theory of general relativity, gravity does not simply pull on objects, it actually bends the structure of space and time together. Near an extremely massive object, like Ton 618, this effect becomes dramatic. To a distant observer watching your spacecraft approach the event horizon, time would appear to slow down for you. Your movements would gradually become slower and slower. Signals sent from your ship would stretch out longer and longer before reaching them. Eventually, from their perspective, you would seem to freeze just above the edge of the black hole, suspended in time. But from your own point of view inside the spacecraft, time would feel perfectly normal. Your clocks would tick at the same steady pace they always had. The strange distortion would only become obvious when comparing your experience with someone far away. This is the strange truth of relativity. Time itself is not absolute. It flows differently depending on the strength of gravity around you. And around something as massive as Ton 618, those differences become extreme. The gravitational forces near the event horizon would also stretch objects dramatically. If you somehow survived long enough to approach the boundary itself, the difference in gravity between your head and your feet would become enormous. Your body would begin to stretch into a long, thin shape in a process scientists sometimes call spaghettification. Matter pulled toward the black hole is gradually torn apart and added to the swirling storm of the accretion disk. Everything that crosses the event horizon becomes permanently hidden from the rest of the universe. Not even light can escape. But the influence of Ton 618 does not stop at its immediate surroundings. The jets launched from the quasar's poles extend for millions of light years. These narrow beams of superheated plasma blast outward at nearly the speed of light, carrying enormous energy far into intergalactic space. They can push away the gas that galaxies need in order to form new stars. In doing so, the black hole helps regulate the growth and evolution of its entire host galaxy. In other words, this single object does not just exist quietly in the center of space. It shapes the destiny of the galaxy around it. And when scientists look at Ton 618, they are witnessing one of the most extreme examples of that process ever observed. Yet, despite everything we know about it, the object still raises enormous questions. Because something this massive should have taken a very long time to grow. But the light we see from Ton 618 shows it already existed when the universe was still relatively young. Which leads to one of the most fascinating mysteries in modern astrophysics. How did something so enormous form so early in cosmic history? To answer that question, we have to step back and look not only at Ton 618 itself, but at the deeper story it tells about the evolution of galaxies across billions of years. When astronomers study TON 618, they are not simply observing a distant object, they are examining a snapshot of the early universe. The light reaching Earth today left that quasar roughly 10 billion years ago, long before our solar system existed. At that time, galaxies were still evolving, colliding, and growing at a much faster pace than they do today. This is what makes TON 618 so fascinating to scientists. Its immense size suggests that supermassive black holes were able to grow extremely quickly during the universe's early years. According to many current models, black holes increase their mass slowly by pulling in gas, dust, and occasionally entire stars. Over billions of years, this process can build enormous gravitational giants. But TON 618 seems to challenge that timeline. For a black hole to reach 66 billion solar masses so early in cosmic history, something unusual must have happened. Perhaps the galaxy around it contained extraordinary amounts of gas. Maybe multiple black holes merged together over time, combining their mass into a single colossal object. Some researchers even consider the possibility that the earliest black holes formed directly from huge collapsing clouds of matter shortly after the universe began. None of these explanations fully solve the mystery yet. And that uncertainty is part of what makes TON 618 so valuable to science. Objects like this push researchers to refine their models and rethink how the cosmos evolved. Each new observation helps scientists test whether their theories truly describe reality. But TON 618 also reveals something else about the universe that is easy to overlook. It reminds us how different our own galaxy might have been under slightly different circumstances. At the center of the Milky Way sits Sagittarius A*, the quiet supermassive black hole we mentioned earlier. Today, it appears relatively calm compared to the violent quasar at the heart of TON 618. It feeds slowly on small amounts of gas drifting toward it, producing only faint bursts of radiation from time to time. Yet evidence suggests that billions of years ago, our galaxy's center may have been far more active. There may have been a period when Sagittarius A times consumed matter much more aggressively, possibly creating a structure similar to a quasar. Astronomers have found large bubble-shaped regions of high-energy radiation extending above and below the center of the Milky Way. These structures hint that powerful jets may once have erupted from our galactic core. If the feeding process had continued longer or more intensely, our galaxy could have evolved very differently. Powerful radiation from an active quasar can heat and push away the gas needed to form new stars. Entire regions of a galaxy may stop producing stars altogether. If something like TON 618 had existed at the center of the Milky Way during its early history, the conditions that eventually created our sun might never have developed. Earth might never have formed. In that sense, the calm nature of our galaxy's central black hole may be one of the quiet reasons we are here today able to observe the universe at all. TON 618 shows us the opposite extreme. It represents what happens when a galaxy's central black hole is fully awake, consuming enormous amounts of matter and releasing energy powerful enough to reshape the surrounding cosmos. And yet, even with all the data scientists have collected, many aspects of TON 618 remain mysterious. How did it grow so large so quickly? How many similar giants might exist beyond the reach of our telescopes? And what does their existence reveal about the earliest moments of galaxy formation? Astronomy rarely provides simple answers. Every discovery opens the door to new questions. The more we learn about the universe, the more we realize how much remains unknown. TON 618 stands as a reminder of that truth. It is not just the largest black hole we have measured. It is a challenge to our understanding, a cosmic puzzle written across billions of light years of space. But there is another perspective worth considering. Despite the immense scale of the universe, despite the violent forces that shape galaxies and black holes, a small species on a quiet planet has managed to discover and study this distant object. Through telescopes, mathematics, and careful observation, humans have measured something that exists billions of light years away and began to understand its nature. That achievement is remarkable. The universe may be unimaginably vast, filled with objects far beyond human scale, but our curiosity allows us to reach across those distances with knowledge and imagination. Even though no spacecraft will ever visit TON 618, we can still explore it through science. We can measure its light, calculate its mass, and understand the physics that governs it. And every time we do, the universe becomes a little less mysterious. At the same time, the cosmos never stops surprising us. New telescopes are already being built that will peer deeper into space and further back in time than ever before. They may reveal even larger black holes or entirely new types of cosmic structures waiting to be discovered. Somewhere out there, beyond the limits of our current observations, the universe is still hiding secrets we have not yet imagined. TON 618 is just one example of the wonders waiting to be explored. And the fact that we can discover something so distant and powerful reminds us that curiosity is one of humanity's greatest strengths. As long as we keep looking up, the story of the universe will continue to unfold. If this journey through one of the most extreme objects in the cosmos amazed you, make sure you support the channel by liking the video, sharing it with someone who loves space, and subscribing so you do not miss the next exploration into the incredible mysteries still waiting out there in the universe.